All right, if you're taking my course, this is not going to be on the exam, but it's another good example of how magnetism is used in real life, and this is an MRI. So you may have gone to the hospital and had an MRI done on you. So I wanted you to have kind of a concept for how does the MRI work. And so you can read all of those captions there. But the basic idea is that your body is mostly made of water. And water is going to be H2O, and we've already discussed that it's an oxygen and then it's got two hydrogens stuck onto it. And then inside each of the hydrogens is going to be a single electron, and then that electron has a little magnet associated with it. So each one of these hydrogens is going to have a teeny tiny little magnet associated with it. So that if you were to put a subject that has water in it and you put it into a strong magnetic field, then what's going to happen is that these hydrogens are going to flip. And so the hydrogens are going to flip so that they are oriented with that external magnetic field. So a MRI has a huge magnet. It has I remember one time I had an MRI done and I was wearing a belt, and the belt was made of metal, and I could feel my body actually being lifted up a little bit due to the strength of that magnetism and that magnetic force. So if you have water, a subject that has water in them, and you subject them to a magnetic field, then those hydrogens are going to flip so that they're pointing in the same direction as the magnetic field. So we need something else. So the next thing is you have a something that is going to be producing radio waves. So you have a radio transmitter that is going to be producing radio waves, and you change the frequency on those radio waves, and at a certain frequency it just so happens that the spin of that hydrogen will flip, and then it will point up when you get to that particular frequency. And so if you have a radio wave that is constantly changing in frequency, then what will happen is that they will be pointing up, and then they'll point down, they'll point up, and they'll point down again. And so they are going to then emit, so these atoms then are going to emit a radio wave of a certain frequency, and then the machine is going to pick that up and then turn it into an image. And so that is the image of a head there as done with an MRI machine. So it's a great device for imaging the inside of the human body. Okay, and then another one that I'd like you to be familiar with is the particle accelerator. So you should now know that when you have a charged particle and then you put it into an electric field, so let's say the electric field's pointing in that direction, then this charged particle will start to move in that direction with a certain force. So the force points in the same direction as the electric field. That means it accelerates. A force makes things accelerate, see? So the force of gravity makes this thing accelerate, so that it's called a particle accelerator. You can make these electric fields by using a battery, basically, to create the electric field, and then the particle will accelerate. And so if you then use magnetism, so now this is going to make it go in a straight line, but then if you surround this thing with magnets, you can cause it to bend into a circle. so that most particle accelerators are circular. And so there is an example of a particle accelerator on the border between Switzerland and France, and it's called CERN. And there it says that that circle there is something like 2 miles in diameter, so it's very, very big. Now what you do is, using your electric field, you're making a particle go around and around and around, and each time it goes around, it's going faster and faster. Then you get another particle going in the opposite direction, and you collide them together. And then you observe all of the teeny tiny little particles that were contained inside of that particle. And so this is how we discovered quarks. So quarks are inside protons and neutrons, and we discovered them by using particle accelerators. Okay, if you want some more practice with magnetism, you can use this review sheet here, and then I have another review sheet on magnetism if you want to look at it. Otherwise, let's take a break, and when we come back, we will do the lesson quiz over this material.